While it lasts.
I don't know. I know everybody says that we're probably not coming back, but I want to believe we are. I want to believe it is going to be October and we are going to come back. That's
the optimist in me says, yeah, we can totally come back.
There we
and then
go.
the pessimist in me is like, if people don't follow the simple rules, there's no way we're coming back. We couldn't even last the full week.
No, we didn't make it a
We
week.
barely, like, the close Tuesday,
No,
Wednesday
no.
would have been the full week. We couldn't last a week.
That's
Like, that's the pessimist in me saying, not gonna happen.
okay, guys. So it's me and Lainey. That's it. That's it. You can see Lainey there. So I'm going to teach Lainey, but I'm teaching you also. I'm teaching you also. Some nuts and bolts. What was due today? WebAssign. So yeah, hopefully everybody's getting on, because that will probably be part of how we evaluate on the quests. Now that they're stealing you from me, we're going to have to be creative in how we actually quest and put those things together. But we'll talk more about that next week. And I'm not sure, we may move that first quest just because of all the transition, but we'll see. Monday. I have no idea what Monday is going to look like, guys. I at the very least, I will come in this room and make a video. I mean, I will just pretend like you're in here with me, and I'll make a video. I will work at the board. I will try. I'll ask questions, and I'll get no responses. But I'll pretend like you're responding. I'll try to give you time. But there's nothing like having a student in the room where you're asking the question, and you realize, oh, they need more time to actually answer it. There's some hope, and I'm not sure this is going to happen. But in an ideal world, what I would love to have happen is that I could do a live feed on Zoom at class time. I could do a live feed at class time, and you guys could call in on Zoom. I would drop this screen, project the Zoom onto here, and I would teach at the blackboard back there, so that you could be here asking me questions. I could be writing at the board, you could be taking notes, so that it would be as much of a live experience as possible. Now, what I've noticed though is that it's hardly clear enough to actually get crisp notes. So I'd probably still film with the iPad and still put that up so that you guys could have the live experience, also have the taped experience, to just make sure your notes are right. Or if somebody's sick and can't get to the lecture, they would still have access to the lecture. But I don't know. That's kind of my dream. My dream is to have you guys up there, kind of like the Disney bubble where they're playing basketball. Yeah. You guys would be on the screen, but we could still possibly communicate. My big fear is we'll get a lot of feedback with the speakers, and we'll get that and that's not going to work. But we'll give it a shot. All I know is it's going to take some time. We're going to adjust. But my hope is that we'll keep moving it better and better and better and better. And who knows? We might be laying the framework for what online education means at JMU. Because the most we can make it like the classroom, the better it's going to be for our students. Okay, why don't we stand up, everybody? So stand up at home. Lainey's just going to stand up here. It's just Lainey. Okay, stretch. All right, let's sit back down. Guys, I mean, we do want to social distance. We do want to stop this spread. For the town and for everybody else. Okay, so but we're gonna do our best to make this as positive experience as possible. So let's start today, because I think a lot of you guys haven't probably worked on factoring for a long time. In fact, Lainey and I were talking, and it so happens that I've got 10 problems up here, okay, for that require factoring. Factoring is such a huge part of this class. So for the next 5 to 10 minutes, what I want you guys to do is get your brains out and try to factor all 10 of these. Now, Lainey, you just keep working, and they're gonna keep. Now, what I would do if I'm just videoing, at this point in time, I'll also say, pause me, and then you would just pause it,
Yeah.
work on it, and then I'd say, unpause me, and then we'd come back and start working again. But I'm hoping not to do that, because I'm hoping we're gonna be live.
What you could do for like a Zoom, I know one of my professors does it as like a synchronous day. So we meet we have the class 3 days a week, but only one day a week is when we do a live Zoom lecture.
Okay,
So
okay.
like Monday and Fridays, she gives us asynchronous work to do. Wednesdays would be synchronous, where we meet on Zoom, in class assignment, we would get in groups and do work together.
Okay.
Or she assigns for us.
Okay. So
And
yeah, so that could be a
helps us.
fallback.
Yeah.
Right, cause still video lectures,
We
put
still
those
have
up.
video lectures, and then
One
we have
day
a
we're
week.
there, maybe be doing a
Yeah.
problem
Yeah.
session day.
And then she splits us up into breakout groups, so we have like a group of 2 or 3 in a separate Zoom call. And
Okay,
we can work together on the project or the assignment that she assigned us, and then she pulls us back to the main lecture,
Okay.
and then we all discuss together.
now how easy is it for you guys to use Zoom and to go into
Oh,
breakout rooms and
It's
all
pretty
that?
easy. Our professor, she assigns us the breakout rooms before we even join the call,
Okay,
so that way all she has to do is like click a button that says start the breakout room, and it just sends us there automatically. And
okay,
then she'll end it, and it brings us back to the lecture.
okay,
So like,
okay,
on a student's perspective, we don't have to do much.
okay.
And Zoom's also a really easy program to use in general. So.
That's what I found that
It's
so
very
much
nice,
easier than
yeah.
WebEx and some of the other stuff.
And you always mute yourself, so like we don't have that much bad feedback. 'Cause it's
Okay.
always on mute. So
Thanks,
pretty
Lainey.
good.
Laying the foundation. Might be really important that you are here. Okay, guys, just keep working, keep working.
I got to 10 and I can't remember how to do 10.
Okay, so Lainey's done. So if you aren't done, you can pause the video and finish. You can pause the video and finish. Okay, I'm thinking for a lot of you, I mean, if you haven't done algebra or pre-calculus in like 3 years, like Lainey, it's been a while. So I want to go back through and talk about factoring. It's not so much I want to teach you how to factor. Your high school teachers did that, and they probably taught you all kinds of different ways that worked for you. But I just want to talk about a couple of the things that I look to that help me with factoring. Okay, so if I'm looking at the first one, in this class, for most of the quadratics we get, most of these quadratic polynomials, the factoring into two binomials is what's going to be key. So we know that we need something that will multiply together and be an x squared. Now what would that be?
X and X.
You know that as long as this is a 1, you're pretty happy. It's just got to be that. Now this is something where I look. The next thing is I look at this, the sign that's back here. I forget about this guy, I look at that sign. If this sign is a minus, I know that these two signs have to be opposite, and that's what helps me. If this sign is a minus, I know that these two signs have to be opposite. One's got to be a plus if it's going to factor, and the other's got to be a minus. So I'll just put those in there, in that location. Now I look at the last term, the constant term, and I'm thinking about factors of 12 where I could get a 1. And you're like, okay, well, you could use 12 and 1. You're quickly like, no, that's not going to work. 6 and 2, you're still probably not going to be able to get to the 1. What's the correct factors?
3 and 4.
3 and 4. And I know I want the final thing to be plus, so I'll put the 4 there, and I'll put the 3 there. And then you can check. I mean, you can check and just say, sure, x times x is,
X squared.
4 times minus 3 is,
-12.
and then it's really these two terms that we got to check. We get the plus x and the minus 3x. And does that give us the 1x? Okay, so let's look at this one. Because this is a minus, I know
They have to be opposite.
they got to be opposites. Now, even though this isn't 1, it's still pretty not bad because it's a prime number. So let's make this,
3.
make this.
X.
Okay, now, you know 1 has to be plus and 1 has to be minus, but you want the thing to be a minus 1 when it's done.
So what the factors have to equal, multiply to get to -12 and add to get to a -1.
So not -12, but negative.
Well, don't you multiply the 4 and the 3 to get -12?
Multiply the 4 and the 3 to get -12. No, you don't need to necessarily do that. You could do that. So let's think of this as breaking a combination lock. Sometimes you just have to go through some of the possibilities. So if I put a 4 here, so let's do that, and then we know 1 has to be positive and 1 has to be negative. So we can maybe make this positive, make this negative. What would this one have to be if you're gonna get a -4? What number would have to go there?
+3.
Positive.
Oh, sorry, you get -4 and -1.
To get the -4 there, what would you have?
Positive 1.
Positive.
Yeah, sorry.
Now let's see if that works. If I check my middle terms, I would get
-12x
and then here I get,
plus x.
and does that get me the minus x that I need there? So you're like, okay, that's not working. Well, what if I put a 4 here and a 1 there?
And they have to be opposite.
They have to be opposite. Now you want the final result to be negative. So where would we put our signs?
Been a while.
No, that's good. This is good.
Oh, I write down stuff and
guys are probably doing the same thing back on the lecture. And this is why I have you guys bust out into groups.
The plus goes at 3x and 4.
Very
and
good.
minus at x minus 1.
And that one goes there, and that one goes there. And if we check our terms, we get 4x and minus 3x.
And then,
We're like, oh, wait, then if I do that,
But then you-
I get the 4x and then the minus 3x, which gives me the 1x, but I need a minus 1.
so do we just flip it then? Yeah.
There we go, there we go. You know, like that's when I don't like that. I've got to think, I got to go through all these different things. But you know, guys, when I think of factoring, I know this analogy. Has anybody ever had, Lainey, did you ever have a combination lock? Like the kind that you
Yeah,
do this?
in middle school.
I always forgot my combination, and then for some reason, I thought just maybe I would hold it up to my ear, and somehow I could hear the combination, and it never worked. But sometimes breaking these down is like breaking a combination. Sometimes you just have to try a couple of different things, and it's okay. We want it to be done, we want it to be fast, but it doesn't really matter. Take your time. So let's go to the next one.
You're gonna need an x in both.
You're gonna need an X in both.
Yeah.
Now, this sign is plus. This is the first time we run into a plus. If you have a plus here, guys, then both of the signs have to be this sign. So when this is plus, both of the signs have to be this sign. So I know both of them have to be minus. I know both of them have to be minus. And then you're like, well, I need factors of 6 that could give me a 6. And you're like, okay, well, let's try 1 and 6. And you try that, and you'll quickly realize that doesn't work. You get a minus x and a minus 6x, that's minus 7.
Mhm.
You try maybe 3 and 2, and you get a minus 2x and a minus 3x.
Which is also not so.
Not going to work. And those are all the factors we have. So this guy does not factor. So here's an example of where sometimes quadratics aren't going to factor. And you're like, well, Dr. Warren, what would I rely on if it doesn't factor and we've got to solve for something? It's something you don't remember, it's something you don't like. It's called the quadratic formula, the quadratic formula. Do you remember that?
I heard in a video you guys singing it yesterday.
Yes, okay. This is if we're solving an equation. If you're solving an equation, like for example, this would be a 1, B would be the negative 6, and C would be the 6. So if I was solving this, which we'll often be doing, my two solutions are, now let's think about that song. It's negative B, negative B,
Plus or minus.
square root. What?
Oh,
You know there's a
it's all
fact.
over 2a.
Okay, over 2a. I wish you guys could be singing with us. What goes in here?
See, your song is different than my song.
No, okay, that's okay. You sing
I don't
your
remember
song.
my song.
You sing your song.
I don't remember how it goes. Negative b. Is it like a squared?
Close. It's b squared minus, good.
Is it minus c?
There's a c in there.
AC.
There's an AC, and then there's a number that goes in front of it. Is that number in your grade?
4?
It's a 4. There you go. There you go.
Jeez, that's a long to
So let's say it again. It's
go. Negative b plus or minus the square root b squared minus 4ac all over 2a.
like Lainey's like, why did I come? Why did I come today?
Right, the only one.
No, so, yeah, all these questions are going to me.
Right?
So if I was trying to solve this equation, who would A be?
1.
Okay, so everywhere where I saw an A, I put a 1. Now, who would the C be? Who would the C be?
6, a positive.
So that would go there. And that just leaves your B. Who's your B?
-6.
So I would have a minus 6. That minus is there, that's coming from the B. Then a -6 parentheses squared. And then what you're gonna do is you're gonna get out your calculator and you're gonna have it do a bunch of the work for you. Now look at me guys, okay, and you look at me too. I'm not gonna make you guys use this a lot, but if you run into a problem and it doesn't factor, don't try to make it factor, because you can always use your quadratic formula. So you're like, thanks a lot, Dr. Warren, you gave me a bad one. Okay, so now let's go to the next one. So I'm looking at this. What are the only two factors that would give us a 3x squared?
3x and x.
3x and x. Okay, now since this is minus, I know one's got to be plus and one's got to be minus. I want a -4 in here, and I've got this 4 back there. You're like, well, I don't know, Dr. Warren, let's try some combinations. What are some factors of 4?
2 and 2.
So let's try 2 and 2. I know one's got to be plus and the other's got to be minus. So what do you think, Lainey? I mean, it doesn't matter. We can always switch it.
Let's just do the negative first and the plus second.
Okay, let's try that. And let's see if we broke the combination lock. So if I'm looking at it, I would have a
-2x.
and then a
6x.
and when I add that together, I get a.
-4x.
Well, I think I get a
Oh,
positive.
sorry, positive. I was looking at the
We're like we want it to be a negative
So
one.
flip flop it.
Flip flop it.
Keep the same 2's. Just like flip flop it. See how that is. Then you get a positive 2x and then -6.
And then have you broken
you
the
get
combination
-4x.
lock?
Yes.
So you open the combination lock. So we know that this should be our +2
-2.
-2.
There you go.
Okay, let's go down to the next one. This one at least starts easier. We got a,
X and x.
because this is minus, I know one's gonna be plus, one's gonna be minus. What are some factors of 15 that might give you a 2?
A -5 and a +3.
A -5 and a +3. -5 and a +3. Okay, let's look at number 6. And you're like, Dr. Warren, that looks like a mess. Now look at me, guys, okay? Focus. Notice here, you've got a 3 here. Is there a factor of 3 in there?
Yes.
And is there a factor of 3 in there? So let's make our life a lot easier.
Pull out the 3.
Pull out the 3. So I'm going over here.
And just rewrite it all.
I do need to rewrite it all. I have a 3x squared. What would the middle term be if you pull out a 3?
2. Put a -2.
And then what would you have if you pull out a... And all of you at home, you're like, oh, Dr. Warren, you know how long I spent on that one trying to figure that out? Now this is a lot simpler. This quadratic's a lot simpler because I know this is going to have to be, the front terms are going to have to be...
X and x.
Now you want factors of 8 when you combine them to get a 2 to unlock this thing.
-4 and a +2.
-4 and a +2. -4. And for those at home, I know Lainey gets it, but for those who are trying to remember, you multiply those guys and those guys. So it'd be -4x plus 2x, which gets Lainey that there. So this is the combination. This is the combination that unlocks this guy. Now this next one, you're like, where's the middle term? But this is called the difference of 2 squares. I always liked these in high school.
So easy.
Because it was so easy. I know it was just going to be One's gonna be plus, one's gonna be minus, because the sign's minus
And
there.
then X and Y.
X and X, and then things that are the same that multiply be
8.
8 and 8 and 8. So I always like that. Okay, let's go to number 8. Dr. Warren, this is so boring. You know, guys, I know it's boring, but it's been a long time. And this is such an important tool. This is such an important tool. All right, laning, because this is a plus,
They're both going to be the same size.
they're both going to be the same sign. So both of those are going to be plus. Now, I know this is going to be X and X. What are factors of 16 that could give you an 8?
4 and 4.
4 and 4. And so there's the combination that unlocks that one. Now you guys are gonna be mad at me again.
But you can pull out a 3.
You can pull out a 3, and when you do that, you get.
X squared minus 2x plus 1.
And I think this is gonna make it a little bit simpler. We know it's X and X. This is a plus, this is a plus, so both signs are,
The same.
and they have to be that sign negative. So we know that. Since this is a plus, both signs have to be that negative. Now, what are the only factors of 1? What are the only factors of 1? So if it's gonna factor, that's what it's gonna have to be. If it's gonna factor, and we can just check it. We get a minus 1x, a minus 1x, which gives us our minus 2x. And number 10, and I know a number of you guys are like, I don't even know what to do, Dr. Warren. Well, let's kind of do what we did here in the beginning. You're like, no, Dr. Warren, there's those extra x's. But we can pull something out.
Yes.
What can we pull out?
A 6x.
A 6x, very good, Lenny. And when we do that, now it's going to take a little bit. When I pull a 6x out of this last term, what's going to be left?
4x. A negative 4x. And then you're left with x. Or sorry, negative 4.
Negative 4, right?
X squared.
And you're left with x squared.
Which, like you said, in number 7 is a different squares.
Very good, Lenny. And so then we know that it's going to be not so bad.
Exactly.
Times x plus 2.
Yeah.
So was this useful? Was this useful going
Yes.
back and reworking some of these things?
Remembering how to do it is very helpful.
And that's it, guys. I mean, you're like, okay, I'm dumb. I don't. But no, it's just you haven't been around it a long time. It's been so long since you've seen it. So it seemed worth to me to invest 20 minutes because it's such an important tool for the class. Okay, stand up and stretch. I know, and you guys better be standing up at home. Because it's only laning, and I've got 35 of you guys. I'm believing it's going to be so much better that in October, we're all going to be in class together. No A day and Z day. This is what I'm believing. I'm believing in a total fairy tale, because that's what I want. That's what I want.
I like the optimism.
That's what I'm believing. This is what I'm believing. Okay, stretch again. Okay. Now, I'm going to show you guys our worst enemy in this class. The worst kind of functions for calculus, at least the ones we have to deal with. They're functions that look like this. They're functions that look like this. So you write that down. I'll give you guys a moment. You write that down. Then we'll talk about what these functions are. Okay. We call these functions piecewise defined. Piecewise. Do you kind of get why they're called piecewise? You're like, I don't know, Dr. Warren. Well, they're kind of broken into two parts. Pieces. They're broken into pieces. Now, I don't like to call these piecewise defined, even though it makes sense. I want to make them scarier, a scarier name. Okay, so I call them I know I didn't spell this right. I call them Frankenstein functions. And you're like, Dr. Warren, why do you call them Frankenstein functions? Now you guys don't need to draw Frankenstein. But I call them Frankenstein functions because I think Dr. Frankenstein went to the graveyard, dug up dead bodies, and sewed the dead bodies together, shocked the thing with lightning, and created the monster Frankenstein. And this is what I want you guys to be afraid. I want you guys to be afraid of these functions because these functions can cause us all kinds of problems in calculus. You know, like, well, Dr. Warren, how do Frankenstein functions work? Well, it's kind of like you've got the legs from one human being. It depends how many pieces there are. There's maybe the torso from another human being, and then we've got this upper part from another human being. So we've sewn these things together in pieces. Part of the time you're on one body, part of the time you're on another body, and part of the time when you're on another body. Where you sew them together, those are the important points. And you say, well, how do I know that, Dr. Warren? What's these parts over here? I'm going to use x squared whenever x is
bigger than 2.
and I'm going to use
2x plus 1 if x is 2 or less than 2.
perfect, Lainey. Okay, so I'm gonna have you guys find some value. Find f of -1 and find f of 4. So you try to find what the function would give for those two values. Okay, so 2 is kind of the place where we divided the person. When I'm less than 2, when I'm less than or equal to 2, I'm going to use that function. But when I'm bigger than 2, I'm going to use the function x squared. So now I'm looking at -1, and I'm on a number line, and here's 2. Which side of the number line am I on? So which body part would I be using? The 2x plus 1. So I'd be using this, and so I would have f of -1 would be equal to 2 times -1 plus 1, which is -1. Did you get that, Lainey?
I did.
Did you guys get that at home? Oh, good, you did. And some of you are like, Dr. Warren, I didn't. I'm still confused. So let's look at f of 4. Let's look at f of 4. Now again, here's the dividing line where we're sewing the functions together. We know we're using this function here, and we're using that function there. I've got 4, so which body part am I going to be on, guys? Which body part?
The x squared.
The x squared. So f of 4 would be equal to 4 squared, which would be equal to 16. Does this make sense? Does this make sense? And then we could plot this, but it'd be kind of broken into pieces. I'm not going to plot it. You can look at the book, they have all kinds of examples like that. Now, you guys might, in Lainey, you might, the first person, oh, I can't believe I'm taping this. The first person I dated, I'll use a code name, okay? I'll just call her Cindy. I was in 7th grade. I still can't believe I ever dated anybody. But it was kind of the first girl that ever showed any interest in me whatsoever. I was in 7th grade. I wasn't athletic. In 4th grade, I had this disastrous moment where it was right before lunch, and Mrs. Rockefeller was my 4th grade teacher, and I had to go to the bathroom, and it was like 5 minutes before lunch, And so I raised my hand and I go, she goes, yes, Paul. And I'm like, Mrs. Rockenfeller, I gotta go to the bathroom. And she's like, just wait till lunch. And so I just waited. And I kind of like the girl Melissa Dallas. And Melissa Dallas in the seating chart had been put right beside me at that point in time. So Melissa Dallas was here and I'm there. And you know, everybody liked Melissa Dallas. She was the one that everybody liked in class. So there was Melissa Dallas and I happened to be sitting right beside her. And then I raised my hand again and she's like, Mrs. Rockenfeller's like, what, Paul? And I'm like, I gotta go to the bathroom. And I lowered my hand. And then she's like, just wait. Lunch is in 2 minutes. And then I raised my hand again. And I don't know what part of raising my hand is connected to my bladder, but then suddenly everything started going. And no matter what muscles I tried to contract, it would not stop. And I could feel it running down my legs, and then I felt it running out my shoe, and then I saw it run in a puddle right toward Melissa Dallas. And then I was like, oh my gosh, and then Melissa Dallas saw it and realized it was me peeing on the floor. And at that point in time, I got up and I ran to the bathroom. I ran to the bathroom and I was in there and I had urine in my socks and my pants. And the only thing I could do was just like, I gotta get this off me. Because I hate being wet, so I'm throwing everything off on the floor and I'm just sitting there. I'm like, beam me up, Scotty, beam me up, Scotty. Make this disappear. Maybe this is a bad dream. Dreams go this way. And then, unbelievably, Mrs. Rockenfeller comes in the boys' bathroom, opens the door. I've got nothing on from the waist down. And she looks at me and goes, are you okay? And I just looked at her in disbelief. Am I okay? I just pissed on the floor. Melissa Dallas is right beside me.
Oh my God.
So needless to say, you know, anybody in middle school, I wasn't date worthy after that point in time. I was the kid who pissed his pants. I walked out, she called my mother took school. I'm like, Mom, I've got to go to a Christian school. I got to get out, you got to take me out of school because I can't ever go back to this school. The janitor was throwing sawdust all over my urine. That was my last scene as I walked away that day. So nobody showed any interest in me. Okay, but there was this one girl in 7th grade, we'll call her Cindy, who did. And Cindy, was a lot of fun. Cindy liked to do things. She was super charismatic. And one day we were out having fun, and I was like, well, what do you want to do? And she goes, well, do you want to see a movie? And she goes, no. I'm like, well, okay, well, do you want to go bowling? And she goes, no. And I was like, okay, well, what do you want to do? And she goes, let's go shoplifting.
Oh.
And I was like, oh, what did you say? Let's go shoplifting. That's a lot of fun. And that's when I realized that Cindy had a darker side. That's when I realized that Cindy, and that's when I was like, Cindy, maybe we shouldn't be seeing each other anymore. Okay, and this is the function I want to talk about that drives my students crazy. Okay, this function right here is like Cindy. It looks like a regular function. You're looking at it and you're like, okay, f of x equals the absolute value of x, g of x equals x squared. It looks like a normal function, but you don't realize it's bipolar. It's bipolar. Even though it looks like a normal function, just like Cindy looked like a normal function, it's really a Frankenstein function. It's piecewise defined. Now here's the pieces. The pieces are much easier. The pieces are much easier than the pieces like this, and that almost makes it harder. The two bodies are, one is just x itself. And this is what I'm going to miss. I can see here Lainey's got to take a moment, write stuff down, and I'm just going to keep going blah, 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 and I'm not going to have any cues for you guys unless I can get this live stream going, guys. So we'll see. If I get a live stream, will you join?
Yeah.
Okay.
It's better than it's live.
Okay. Even if it's a little blurry.
I'll be on it. I promise.
Okay. Here's the other function. So instead of being 2x plus 1, and x squared, it's the function
X,
and the function
negative X.
negative x. Now where's the suture line? Where's this suture line that was so important that we needed to actually evaluate the function? What's actually at 0. We use the top function if x is greater than or equal to 0.
And then if X is less
We
than or
use-
equal to.
This if x is less than 0. So let's draw the body here. Here's 0. Here's 0. So Lainey, if I pick numbers on this side, which function will I use?
The negative X,
If I pick functions on this side, what will I use?
positive X.
Okay. So now you guys should answer that too. Now what we're gonna do is we're gonna do the exact same thing. We're gonna do the exact same thing that we were doing here, okay? So I'm gonna look at f of negative 1. And I'm gonna look at f of 4, and I want you to find those.
I have a quick question.
Yeah,
Just like for
no, good,
memory's
good.
sake. So the top function is greater than or equal to, but the bottom is less. How come, and it's the same thing over here, but the signs are flipped. How come the top is equal to and the bottom is
Well,
not?
it doesn't
Like,
matter.
whatever the sign
That's a
is.
good, I could have put the equal to here, or I could have put the equal to, I can move it around.
Oh, so it's not.
It doesn't
always
matter,
in
no,
the-
it's not in a location, you can put it with anything.
So it just varies. Oh, okay, got it. Okay.
We can't have it with both.
Yeah, so just like one or the other.
Right.
But it doesn't, it's not always gonna be on the top.
Right.
Okay, got it.
So what's the definition of a function? You're like, oh, Dr. Warren, please,
It's the
what?
relation that assigns, or that
Good, good,
has
good.
like the domain value that is assigned to a unique range value.
That's great, Lainey, that's great. That's a relation that assigns every element in one set called
Domain
a unique element in a second set
of the range.
of the range. So imagine that I went here. Now don't, guys, this is a mistake, so and I did that. So I've got it here and I've got it there. Then if you're hitting f of 2,
It could be either.
it could be either. And you're like, okay, well, this would be 4, but if I use this one, it could be 3. Do you see how you'd be violating that uniqueness?
Yeah.
You see, so it can only go to one of them. So Lainey asked a great question. So I could have done this. I could have made it the 4, and it's still.
As long as they're not together.
As long as they're
Like,
not
you don't
together.
have a greater than or equal to and a less than or equal to.
Perfect,
Okay.
perfect. And you could even do this, I won't do this much. You could say when it's exactly equal to 2, make it 12.
Okay,
You know, you just can't violate that uniqueness.
okay, got it.
So here 0 would go with this guy.
Mm-hmm.
So f of 4 would be
Just 4.
just 4. F of negative 1 would be,
You would use the negative x, and then it becomes positive 1.
it becomes positive 1. Okay, so this is this function. An absolute value, I mean, you can learn about the absolute value maybe in elementary school.
Probably that, or at least early middle school.
And it seems pretty easy in the beginning. You're like, okay, it's a positive making machine. The absolute value of 5 is,
Negative 5.
sorry, the absolute value of 5 is,
5.
there you go. The absolute value of negative 5 is
Negative. Or wait, so the positive 5.
positive 5.
Got it.
So in the beginning, it seems pretty simple.
Mm-hmm.
It always makes things,
It looks like a Frankenstein, so it looks scary, but
right.
it's easy.
So let me see if I don't want to make it more confusing. When you first learn, Lainey, about absolute value back in middle school, we think it just makes it positive.
Okay.
So the absolute value of 7 is just 7.
And then negative 7.
The absolute value negative 7 is 7. Then you hit high school, and then they start talking about the absolute value function, and it gets a lot harder. they go, it makes a V. Do you remember that?
Mhm.
And the reason it makes a V is because it's this function. If you plotted the line equals y equals x, this top function, it looks like this. If you plotted that line, it's got negative slope. So it looks like that.
And that's what it should be.
And so if I, using this fails the vertical line test, you see?
Yeah.
But I'm only gonna use this branch when x is greater than or equal to 0. And I'm only gonna use this branch
When it's
less than 0. And do you see the V shape it makes? So it's really the fact that it's a piecewise defined function that makes it a V. So in this class, when we talk about the absolute value of x, I'm gonna so miss that moment right there, where it's just, in this function, when we talk about the absolute value of x, this is what I need in our head. Because if not, we're gonna make mistakes. Now let's just make sure it works. What's the absolute value of 4?
4.
What's the absolute value of -1?
1.
Is that not what we got out of our function?
Mm-hmm. It is.
So let's just go back to the 5. If I put a 5 in here, would I use the top part? If I put a 5 in, would I be using the x or the minus x?
That.
And so I would get a 5 back out.
Mm-hmm.
But if I put a -5 in, would I be using the top or the bottom?
The bottom.
And so I take the negative of it, and the negative
Positive 5.
is still positive.
Yeah.
And so I call this my Cindy function. When I think of absolute value, and I think all of us have friends like that. Isn't there some friends like they just, in a moment, they just snap, you don't see it. And after you know them for a while, you're just kind of like, whoa, there's something a little darker about you. And then, and it's worse when you're dating them. It's kind of like, oh my gosh, how do I escape this? Sorry. Okay. Thank you for coming today. I'm just going to stop here, guys. I'm just going to stop here. I want you guys working in the homework into 1. And I'm going to try to find us a solution. For next. Our first quest will probably be not be next Friday. I'll probably move it since we're moving online. I'll probably make another WebAssign due next week, just to get you guys working with WebAssign some more. Now, are you staying here, Lainey?
Yeah, I have an off-campus apartment.
Okay.
I'll
Okay.
be.
Now, do you have roommates?
I have 3 of them.
Okay, and everybody's managed so far to stay healthy?
So far, I mean, most of us have they've either been at their boyfriends or they've been at our place.
So they haven't really seen a ton of people.
Yeah.
right?
They're all just keeping to themselves. We all stay in our own rooms. I mean, like, I hang out with one of the roommates because she was my roommate last year and freshman year.
Oh,
So
wow.
we already know each other. We met each other's families.
Oh,
so
that's-
we hang out more than the other two.
That's,
So I mean,
well, just keep me aware.
Yeah.
Like if things happen, just say, Dr. Warren, this isn't going right. And guys, where you're at in video land, let me know. When things aren't working, what I'm doing, what I'm giving you isn't working, let me know. Or if you're sick, let me know. And we're gonna make it through.
it'll be hard, it'll be interesting, but take it from someone who was here last semester when we all went online. It's hard at the beginning, but it definitely gets better.
Okay. Did you hear that, guys? Did you hear
It'll
that,
get better, I
freshmen?
promise. It's
That's-
annoying, but I promise it definitely
It is annoying.
It gets so much better.
And then you have to listen to me monitor more of our video.
Yeah. But, I mean, also it's kind of nice when you do everything asynchronously, because you can do it on your own pace.
Right.
And that definitely helps with people who, I know for me at least, when people, like my professors talk fast and teach, it's hard to keep up. And especially with videos, like with yours. If I miss something, I can rewind it and go back. So I mean, that's kind of the benefit of online classes, is you do work at your own pace and can relearn stuff, rewatch it all, instead of the live lectures. It's just, the live lectures are a lot better too. At the same time, because you're getting that interaction that you do need for an education.
I need that interaction, guys. I just need it. So I'm gonna try to give you both. We're gonna try to give some live
Definitely.
portion and we're gonna video so that you can have both.
Oh yeah, it definitely helps. It's annoying, trust me. It was awful last semester, but it's still pretty good. It'll be fine.
I would have failed. I just know I would have failed.
Hey, for freshmen, when I took stats last semester and it went online, I got an A- in the class.
There you go. You
So
hear it.
online
This
does
is
help.
and the Science and Math Learning Center.
Yes,
You know, that-
please do that.
They've got those video appointments, so
Mhm.
so you guys should take advantage of those too.
Yeah. It'll be fine. It'll be fine.
All right, Lainey. I'm
Thank you so
seeing you.
much.
I'm seeing you in October. I'm believing.
Yes. I'm here. So
Okay.
Zoom, I'll be there.
Okay.
Bye.
Thanks, Lainey. All right, guys. I'm so sorry. I'm so sorry. We may try this live thing on Monday, or we may I may just make a video Monday where I'm hoping to get something where we do a Zoom live. I'll let you know more as the weekend goes on. All right. Thanks.